Welcome to my video. Thank you for clicking on this video, and I'm going to discuss the sigma notation. So stay tuned. Right. So to help me explain what a sigma notation is, I am going to use three examples, right? After that, those three examples, I guarantee you that you will fully understand what sigma notation means. Let's start. Example number one. Right. The question says evaluate the sigma notation, right? So, what is a sigma notation, right? A sigma notation is simply a series, right, in a specific order, right? If a series is put into this order, it's therefore called a sigma notation, right? Now, what are the components that make a sigma notation? The first component is what you see here, right? This is the first component. R equals to 1. This is the first component that makes up a sigma notation, right? This is now the second component, right? The top number, that is your second component, okay? And you have got a sign here, like that looks like an E. That is your third part. The third component that makes up what? A sigma notation. The last one is that. All right. So we've got that part, which is an expression that makes up what? A sigma notation. Okay. So you know 4 parts that makes up a sigma notation. Okay. Just going to erase. Okay. So now we know all 4 parts that makes up a sigma notation. I've got 3 steps that I want us to go through, right? When a question says evaluate a sigma, a sigma notation, right? What do they mean? They mean that you need to calculate a sum of a sigma notation. You need to calculate the sum of this series. This is a series, right? You need to calculate the sum of this series, okay? Now, the first thing that you do, you need to expand. Okay, so when you expand this into a series, right? So you're going to expand this sigma notation into a series, right? Or terms, right? That you are going to add together. That is simply a series, all right? So when we expand, right, we are going to say T1, meaning the first term, all right? So the first term, you take this expression as it is, right? So it's 3R1 3 over 2. So for first term, right, this will be R1, right? This is always R1. Let me see. Always a replacement for first term. Okay? This. It's always, whatever that you see here at the bottom is always a replacement for your first term. Okay? Let's continue. What is the value of R1? It's 1. 1 minus 1, 3 over 2, right? So this will give me 3. 1 minus 1, 0 times whatever that is here, 0. 3 plus 0, 3, right? That is my term 1. Okay. Now for term 2, right? What is the value of R2? For term 2, the value of R2, you take R1 plus 1. You always add whatever value of R, the previous one, and you add 1 to get the next value of R. Okay? So what do we have? The previous R1, we had 1, and then plus that 1, which will give us a 2. Okay? Therefore, T2 will be, you take the expression as is. This is R2, 1, 3 over 2. Okay. So you do replacements. 3. What is the value of R2? The value of R2 is your 2 minus 1, 3 over 2. Okay. So this will be 2 minus 1, which is 1, right? And when you punch this into your calculator, what are you going to get? You're going to get 9 over 2. Okay. So meaning 2 term 2 is equals to 9 over 2. So I've got term 2, right? I'm going to go ahead and calculate term 3. Term 3, right? So for term 3, what is R3? R3 is R2 plus 1, always. What is R2? R2 is 2 plus 1, which is equals to 3. Therefore, T3, right? You take the expression as is. So this will be R3 minus 1, 3 over 2. Okay? 3, R3, which is 3 minus 1, 3 over 2. So this is 2, which will cancel that 2. Therefore, I'll have 3 plus 3, so which is 6. Don't worry, you can punch this into your calculator. There's no need to do it from the top of your head. So I have T3, right? Now, let's do this. I have T1, T2, T3, right? Remember, I'm trying to expand my sigma notation. Now I want to calculate the last term. So how am I going to go about that, right? The last term is TL. Okay. So what is R for my last term? So R for my last term, right? This will be RL. So which is always a replacement for last term. Okay, so the value there at the top is always your replacement for the value of r if you want to calculate the last term. Okay, therefore RL is now equals to 13. So TL, you take the expression as is, 3 plus RL minus 1, 3 over 2. Okay, so 3 plus 13, 1, 3 over 2. Okay, put this into your calculator, you'll get 21. So basically 12 divided by 2, which is 6. 6 times 3, 18. 18 plus 3, 21. So our series would therefore be term 1, which is 3, plus term 2, which is 9 over 2, plus term 3, which is 6. We don't know what is in between. Then the last term will be 21. So this is our series, right? Do you know what type of a series this is, right? So let's take it to the next slide. So from the previous slide, we had a series 3, 9 over 2, 6 plus 21, right? What type of series this is? So I'm going to check first if it's an arithmetic series. If it's not an arithmetic series, I'll check if it's a geometric series, right? So 9 over 2, which is 4.5 minus 3, this will give me 1.5, okay? 6 minus 4.5, which will give me 1.5, right? So from this, I can tell that it's an arithmetic series. Okay, so this is an arithmetic series, right? Therefore, Sn will now be n into a plus l all over 2, right? Why did I use this formula? All right, if you haven't watched my video on arithmetic and geometric series, please make sure that you do watch that video. You'll get more details as to why I use this formula. But I'm just going to give you a glimpse of of the reason why I used this formula, right? The reason why I use this formula is because this is my last term. I know the value of my last term, right? So from this series, I know the value of A, all right? So what is it that I do not know in this series, all right? So remember, if you have a sigma notation, right, you will have the bottom number, right? So it can be I equals to 3, that is your bottom number, okay? And you'll have your top number, okay? Which can be, let's say, 8, right? Now, the value of n. The value of n will be your top number right minus your bottom number plus 1. Okay, so let's check what we have here. This is the top number and this is the bottom number, right? So the top number is 13 minus, right? What is the bottom number? The bottom number is 1. So it's 1, then plus that 1. So this is how you calculate the value of n, right? So basically the number of terms, okay? So you take the top number, subtract the bottom number, and add 1. So if you had something like this, you take the top number, which is 8, subtract the bottom number, and add 1. So this will give you 8 minus 3, which is 5 plus 1, which is 6. So the value of n will be 6, right? I hope that makes sense. So let's go ahead, right? Continue from there. Now, I have calculated the value of n, right? Therefore, I know that n is equals to 13. Therefore, as 13 will be, the value of n is 13 into a. A is 3. Plus, I know the value of l. It's 20, 21 all over 2. So, save yourself some time. Put this into your calculator. What you get is 156. All right. Let's move to the next example. So let's use example 2 to further explain the sigma notation. All right. The question says, determine the value of n, right? That value of n. If the sigma notation is equals to 381. Okay? This is the same as Sn, right? Meaning the sum. This is the sum of this. So it's the sum of the whole series. That is clear, right? Now, remember, when you are given a sigma notation, what you need to do is expand. Let's do that. Expand. So when you expand this into a series, right? So, term 1. Okay, remember, right? So the value of k, this will be, this at the bottom will be for k1, which is used as a replacement for first term. Okay, so for t1, k1 will be 1, right? So we know from that sigma notation. Okay, therefore t1 is now, you take that expression as it is, 3 to k1, right, minus 1. Then we do replacement or substitution. which will be 2. Therefore, K1 we know it's 1 minus 1. So this will be 0. 2x raised to 0 is 1. 1 times 3, that is 3. Don't worry. Put it into your calculator and you don't have to stress about anything else. So I have determined the value of T1, right? Let's go to T2. T2. What is the value of K2? Right? You take the last or the previous value of K, which is K1, and you add 1. So K1 was 1, so 1 plus 1 is 2. Okay? Therefore, T2 will be, you take the expression as is, 3 into 2 K2 minus 1. Okay? So this will be K2, which is 2 minus K. So it's K2 minus 1. What do we have? So it's 1 there. So it's 3 times 2, which is 6. Okay. Let's continue. T3. What do we know K3 to be? So K3 will be K2 plus 1. What was K2? K2 was 2. Therefore, 2 plus 1, 3. Right? As a result, T3 will be, you take the expression as is. So this will be K3 and you substitute. K3, that will be 3 minus 1, right? So this will be 2 and 2 squared, or 2 raised to exponent 2, which is 4. 4 times 3, this will be 12, all right? Now, I want to do the last term. The last term will be TL, right? What do we know? KL will be the top number. So I don't have a number there, I have N, right? So as a result, the last term will be, take the expression as is, right? What is, okay, KL minus 1. So this will be, KL is N minus 1, right? So as a result, right, our series, therefore, our series will be term 1, which is 3, term 2, which is 6, term 3, which is 12. I don't know what is in between the last term, 3 and minus 1. Okay, so this is my series. Okay, from this, right, I'm going to check if it's an arithmetic series, right? Let me check. 6 minus 2, 6 minus 3, this is 3. 12 minus 6, which is 6. So these two are not common. Therefore, it's not, this is not an arithmetic series, right? Now, let's check if it's a geometric series. So T2, T1. Okay. T3, T2. Right. What is T3, T2, T1? So T2, T1, which is 6 over 3, and this gives me a 2. Okay. And this is T3 over T2. T3 is 12 over 6, which gives me a 2, right? So I've got a 2 here and I've got a 2 here, which is common. Okay, so this is common. Therefore, I have got a geometric sequence, series. I have got a geometric series, right? Let's move on to the next part. So before we move on to the next part, remember your Sn is equals to 3, 8, 1. Okay, and the value of R is equals to 2. So from the previous slide, we know that the value of R is equals to 2, and then the sigma notation and k equals to 1, 3, 2, k minus 1, 3, 8, 1. Okay, so we did establish this is Sn. This is the sum of this sigma notation or the sum of the series. Okay, so I know the value of 2, I know Sn, right? So remember, so the sum or Sn, right, would either be a Rn over 1, R minus 1, or Sn can be a 1 minus Rn all over 1 minus R. We only use this one, right? We only use this one when the value of R is greater than 1. So, and we use this when the value of R is less than 1. Okay, so I'm going to erase that because the value of R is equals to is greater than 1. Okay, what is the value of Sn? 381, right? So remember our series was 3, 6, 12. Okay, so our series is 3, 6, 12, 3, 2, and minus 1. Okay, so from this you can tell that the value of A is equals to 3. This is your first term. Okay, so I'm going to do the substitution, which is 3. What is the value of R? 2, and the value of R here is 2 minus 1. So 2 minus 1 will be 1. This will give me 381, 3, 2, and minus 1. Divide both sides by 3, right? What do you get? 127, 2, and minus 1. Okay, take this to the other side. 128, 2, and right? So I'll have 2 on this side, and I want to put 2 here. I just want to find out what is a number that I can put here that will give me, as a whole, this will give me 128, right? That is 7. So if I put 7 there, put this, the whole thing, 2 raised to exponent 7, it will give me 128. Okay? So remember, the exponent loss, right? So if the bases are the same, right? You need to equate the exponents. All right. So bases are the same, 2 and 2. Then you equate the exponents. So 7 is equals to n. Therefore, n is equals to 7. Go back to the question. The question says determine the value of n, right? That's what we exactly did. The value of n. Okay? Just a tip. Please make sure that you practice a lot so that you can get the hang of this, right? So know when to use certain type of formulas or equations, right? And yeah, watch more of my videos. If you want to repeat this video, repeat, pause, take notes, and if there's not something that you do not understand, please drop your questions down in the section below, and I'll make sure that I give you clarity on that. Let's move on to the next part. The last example is example number 3. All right. So example number 3, this is the last example. What is the greatest integer value of m? So what is the value of m for which this is a sigma notation is 511, right? So if the sum of this sigma notation is less than 511, what will be that value of m, right? So basically, it's more or less like the previous one. You just need to calculate that value, but make sure that that value, if you put that value, right, or if you add up until uh, the number of that value, you get the sum that is less than 511. Okay, 511. So let's get cracking. Remember, you have a sigma notation, which means you need to expand. The first thing that you need to do is to expand. All right. So how do you expand? T1, right? So for T1, what do you have? The value of I1 is 1. So it's always what you have there. Okay? At the bottom. Therefore, T1 will be, you take the expression as is 2I1 minus 1. So when you do replace, it's 1 minus 1, which is all 2 exponent 0, which is 1. Okay? You do the same thing for T2. What do we know? I2 should be I1 plus 1. Okay, so what is I1? I1 was 1. 1 plus 1 is 2. Therefore, T2 will be, take the expression as is. So it's 2 I2 minus 1. 2 I2 is 2. 2 minus 1. So this will give you a 2, right? So you know T1 and T2. So T3, what do we know about T3? I3 is I2 plus 1. Always plus 1. I2 was 2 plus 1, which is 3. Therefore, T3, you take that expression as it is. So I3 minus 1, you substitute I3, which is 3 minus 1, 2, 2, which is 4. Okay? And therefore, the last part, so the last part would be TL. IL will be M. That is the top number, right? Therefore, TL will be, take the expression as is, 2 IL minus 1, 2 IL is M minus 1. Okay? So you have the last term. Okay. Your series is now term 1, which is 1, term 2, 2, term 3, 4. I don't know what is in between. Then the last term is 2M minus 1. Okay. Now you need to determine if this is a geometric or an arithmetic series. Okay. So from first glance, you can tell that this is not an arithmetic series because 2 minus 1, 1. 4 minus 2 is 2. These are not common, right? So these are not common. As a result, it's not an arithmetic series. If it's not an arithmetic series, so it's going to be geometric. So T2 is 2 over 1, which is 2, right? Or R is T3, which is 4 over 2, which is 2. I know the value of R, right? And I know the value of A. Okay, let's continue to the next slide. So the value of R is greater than 1, right? Meaning Sn will be A to Rn. Okay, so Sm will tell you why. Because of this, right? So it's going to be Sm is equals to Rm minus 1, R1 minus 1. Okay. Now, the question says, what is the greatest integer value of m, right? For which this is less than 5,1. Okay. So, for which that is less than 511. Okay, so this is what I'm going to use. All right, what do we know? We know the value of A from the previous slide to be 1 and the value of R to be 2. Keep that in mind. Value of A is 1, the value of R is 2. Right? Less than 5. Okay, what else do we know? Okay, now we're just trying to simplify. 2m, so this is 2 minus 1 is 1, doesn't matter. Take this to the other side. 512 2m, right? So I've got 2m this side. I'm going to put 2 as a base. I want a number that if I put the whole thing into a calculator will give me 512. That number is 9. Okay, so same thing, bases are the same, therefore you need to equate exponents. Okay, so equate the exponents. M will be less than 9. The greatest integer, right? If M is less than 9, what comes before 9? Obviously, that will be 8, right? Therefore, the greatest integer will be 8, right? Meaning, if you say S8, right? So this will be 1. So you put 8 there. So 2 minus 1. This will be 2, 8 minus 1, which is equals to 2, 5, 6 minus 1. This will be 2, 5, 5. Okay. So you can see this value, right, is less than 511. If you've watched up until this far, I tell you what, I really do appreciate you, and I hope you found great value watching this video. And just a small favor, please make sure others know about this channel. Share this video, make sure that you like so that others can see it. Thank you very much for watching. Please watch the next videos that I'm going to upload. Ciao.